much. Welcome, welcome. We're glad that you all could come out and join us today. So it's my privilege to talk about this work that actually started out as a master's project by Albert Kaleem, and he implemented our MIDAS tool basically using a lamp stack. If you're not sure what that means, come see me later. But then Jared and Erin totally re-envisioned this project in Rails. So we're going to get to look under the hood a little bit here today. What we're going to do is, first of all, introduce MIDAS to you. That'll be my part. I'll give you just a high-level look at what is a MIDAS. Then Jared and Erin are going to talk to you about the platforms used, talk to you a little bit about how MIDAS is currently implemented, which is to support traceability work. Then we'll have a demo and a code walkthrough. And I told them to channel their inner Dr. Finkel. So it should be good. Okay, my kingdom for a gold standard or an answer set. It doesn't really matter what particular area you're in. It doesn't have to be tracing, but are you working with tagging, classifying, marking, labeling? Are you doing work with ontologies, taxonomies, natural language processing, interview tagging? All of these things have something in common, which is when you go to evaluate your work and your techniques, you have to have some form of a training set or some form of a gold standard or an answer set in order to evaluate your work and see how accurate you are. We all have possibly this shared recurring nightmare, unfortunately. Oh, yes, ground truth. Your paper is rejected. Well, let's see what the notorious reviewer 2 has to say. Oh, well, I'm really not impressed that your work turned out so well because you developed the answer set, the data set against which your new technique was evaluated. Problem. But what are we to do? Because we have these new techniques that we're developing, we need to be able to evaluate them, and in order to do that, we need these data sets, and we need to know exactly what is the ground truth. So our solution is to have our community vet these answer sets or come up with these gold standards for ground truth. So that's where we came up with this multi-user input in determining answer sets, or MIDAS. What does it do? Well, we currently have it implemented for tracing. And this is basically, Jared will talk about this some more, but basically looking at the relationship between different artifacts in the software engineering lifecycle. So for example, these requirements map to these design elements. These design elements have been implemented in this code. This code is tested by these test cases and so on. Okay, those are traceability relations. So what happens here? The users can upload the data sets. I guess I can get away from this microphone a little bit. Still one. Okay, so they're gonna upload their data sets, and these will go into the MIDAS system, and then the community is going to vote on what they believe are links between these different artifact elements. So the gold standard is then going to be generated based on the community consensus, and in fact, you'll be able to specify what threshold you want to use when you generate the answer set. And this is a very cool feature that Jared added, which is Scott's Pi. So if you think about inter-rater agreement, and maybe you're familiar with Cohen's kappa, he's going to talk about this at great length in a little bit. And oh, by the way, what the community comes up with for this answer set can be compared to whatever it was that you had to begin with. Therefore, we're reducing the bias. And now we'll have Erin. And Erin is at Lexmark now, one of our alumni.
Current alumni, yes. Okay, all right, so what did we use to do all of this? Biggest picture on the board, clearly, this is a Rails app. Once you've used Rails, Rails can be done for any project you can ever think of. Everything looks like a nail when you are holding a hammer like Rails. We used a MySQL database, but we could have used any other SQL implementation of database. We used a few different editors, obviously, and GitLab to host it because this is a UK project. So, for those of you who don't know much about web programming, what is Ruby on Rails? Some people call it just Rails, some people call it Ruby on Rails. It doesn't really matter, both work. It is technically an MVC framework for web application development specifically. And I'll go into what MVC means in just a minute. As I said, it's database agnostic, so you can plug it up to basically any kind of database. It comes with an H3 database, right, by default, but you can change that to whatever you want. It doesn't care. You define all of the relations in Ruby, and then it figures out the database stuff for you so that you don't have to do that manually. It also supports JSON and XML both in the form of making your own API, so both of those are pretty widely used formats, obviously. And it also supports active record pattern, which is pretty popular for web applications. I'll get into that in a second. So, again, for those of you who don't know much about web development, this is the end-all, be-all diagram for how it all works. Please admire it, because it's super great. I didn't make it, I just found it, but it's really cool. So, you, the user, interact with your browser, yes? Router? Is it the Rails router? Not like a legit router, right? Okay. So, MVC stands for Model, View, and Controller. The model being literal data models, your actual objects that you want to store in your database. A controller is how a view interacts with the model, and obviously the view is how the user interacts with the system, right? You view different web pages, and that's how it gets your input. The view sends it to the controller, and the controller uses that to manipulate existing objects or to create new objects and send them to the database, which is completely separated from the other components, which is why any kind of database can be used, because it's not written anywhere else. Controllers are made up of different actions, which each action would have a corresponding view. So a create new item page, that's one action, that's one view. An update or edit new item, that's another view, that's another action. Now, if you want to see what a Rails app looks like, it's so awesome. You're going to be so thrilled.
Hi, everybody. So we're going to skip away from the PowerPoint for a bit and actually show you MIDAS. This is MIDAS. This is a data set that I've uploaded myself, and it contains source and target artifacts for an application's development that presents and creates Gantt charts. Are many of you familiar with Gantt charts at all? One hand. Just to give an explanation for everyone else, Gantt charts are visual representations of the timeline of a project, certain actions that need to be done during a project's lifetime, and how those actions depend on each other. And this is everything that we have. The source artifacts are usually functional requirements that define certain things that the application should be capable of. This source artifact shows that the application should be capable of maintaining task properties and should be able to edit and update them as time goes on. A target artifact, for example, if we scroll down, we have a lot of source artifacts. This is a more low-level requirement of the project, showing that the user interface should be able to display critical path. So the original requirement was a lot higher level. This is significantly lower level in terms of the implementation. What MIDAS is going to do for this is create links between these source artifacts and these target artifacts. I can't do this myself since I'm the uploader of this. However, if I log in as someone else, for example, Erin wasn't too careful with her password, and I know it. I did not.
The password's password.
I can see the data set that I created. And instead of seeing the source and target artifacts, I am presented with a single source artifact and a single target artifact. Can you all see that very well?
Yes.
And I'm supposed to vote as to whether or not I see a potential link between these artifacts. Do I believe that these artifacts are related to one another? So the source artifact is to add and remove tasks links, and the target artifact is that the user interface should provide the ability to show the utilization of the person. So I don't believe these are very related, so I'm going to vote no, and it'll present me with another one. I can do this until I run out of combinations between source artifacts and target artifacts for me to vote on. If I go back to my account, I can see that Erin has been voting on my data set. And I can see links that have been found in my data set. This is a link that someone voted yes on. It says that source artifact R13 is related to D13-1. And after enough links have been generated and enough people have voted, I can download an answer set based on the consensus that everyone has come to, based on their yes votes. And I can compare that to my own curated answer set, what I believe the related source artifacts and target artifacts are. And I'll get into this little detail here, which answers the question, how do we know when enough people have voted? When are we finished? When do we have a useful result? And the answer to that is this statistic, Scott's Pie. Scott's Pie measures inter-rater reliability. Without getting too detailed, because you see there are a whole bunch of different steps in that equation, it is a comparison between the expected amount of people the number of people we expect to come to an agreement and the number of people we actually observe coming to an agreement. And we can apply this by noticing that a data set contains the artifacts, links contain pairs, link categories are typically yes or no, which is a nominal type of data. We also have maybe votes, which if we see that there is potential for a connection, but we're not sure on it, we can provide feedback on that for the uploader to review. And we keep track of the counts. And we can plug these values into the equation, and it'll provide a value between 0 and 1 for us. As that value approaches 1, the votes that have been uploaded have reached a more reliable consensus. And I can show you the code that implements this. This is in a helper file. Helper files in Rails are where we put code that we're too ashamed to admit are actually in our controller, which we're supposed to keep clean. There were a few optimizations that we could make. Since we know the number of categories that we have, we can simplify that to a fixed addition instead of a summation. And because we know that the values that we're dealing with, the categories are nominal, a lot of the combinations of categories, suppose if 2 people oppose, someone votes yes and someone votes no, there's not a lot we can gather from that because we're at a very fixed disagreement. So we can just multiply that value by 0, it disappears, we don't have to worry about it. Erin, would you like to discuss a bit more about Model View Controller and how views work?
So, the data set controller? Is that the prettiest one? Okay. So, as you can see, when you actually make a Rails app, literally all of these directories and files are created. All of them. All of them. It's a lot. It's really intimidating, but basically everything code-wise that you are concerned with is all in the app folder. So here you can see exactly how Rails sorts things out. You have controllers, you have helpers, jobs if you want to run like scheduled tasks, for instance. We don't have anything where we need that, so that's obviously, there's nothing in there. Mailers if you want to send out automated emails for password reset, for example. and then all your views are sorted by their respective controllers. So, looking at a pretty controller, as I said, controllers are sorted out into actions. So each of these is its own action and has its own view, its own page. The cool thing about Rails is that views are quite modular, and you can build them up based on how exactly you need to display things, and that applies to several other portions of Rails as well, such as the CSS and the style sheets of the application. You can make them as modular as you like, which is pretty nifty. I'll show that real quick too. So here we have components, and these are all different files with CSS that definitely, like if you put all of that into one file, it would be ginormous, and that's how most people have done CSS, but that's not super awesome. So Rails makes it a lot easier to see exactly what you need. So let's see. We'll just have to create. So on this create action, you see this format.html. A default call to a certain page on a Rails app, given this setup, implies that it is looking for the HTML version of the page, which means it would return the normal web page saying, create a new artifact, or in this case, a data set, create a new data set, and it would show the form for that. But if you, for example, put .json at the end of that link, it would actually give you the resources behind it, which it would not give you, you would have to post to it. But that's how the JSON API functionality works with a Rails action. As far as the views go, let's see if I can try to show. This is what a form looks like. Pretty basic HTML stuff with some cute little Ruby thrown in. Kind of messy, looks kind of like PHP, but it is very functional. This would be an example of the modularity I was discussing. So this is the entire piece that shows one data set. So if you were looking at a list of data sets, it would actually render multiple of this. So instead of having an entire page filled up with, n many versions of that, it only has one in the whole project, and it just renders that as many times as necessary. So there's a lot of built-in functionality like that with Rails. Models, that was the other one. So, as I said before, Rails is incredibly database agnostic, so all of your relations between objects that you define in your ER diagram prior to making the project, or that you find along the way, you define in the model in Ruby, which, if any of you have taken databases, you might recognize these: belongs to, has many, those kinds of words. Searchable here is a good example of something extra, some fancy functionality that we tacked onto our project, which can be done very easily through the use of Ruby gems, which are basically libraries that you define in a file that you say you want to have available in your project. Basically anything you can think of, there's a gem for that. You can also put validators on here for the actual model itself upon creation. So the way that active record pattern, the design pattern actually works, you create an instance of an object in memory, and then you have to call save explicitly on that object before it actually goes into the database, so you can do all your validations and other processing before you actually save it to the database, which gives a lot of room for protecting against malicious activity or random user error that doesn't help anybody at all. Active record is really cool. Models, views, controllers. That's all the pieces, yeah. What time is it? Not time to go yet. Let's think of something else.
We can also give them time for questions.
Ooh, yeah. Anybody got any questions yet?
Can you walk us through, for example, the validates second to the end? Exactly what does each of those lines mean?
Okay, so something that is really important in MIDAS in particular is the context-specific parts of the application. If a user uploads or creates a data set, it's theirs, and they're not allowed to vote on their own stuff. So obviously that, knowing the context of the person who's logged in and who has ownership of a certain data set is very particular. So for this, it's this validator, we have to make absolutely certain that there is in fact a user ID attached to it, otherwise it won't save.
User ID attached to what?
To the instance of data set that has been created. Must be there.
What are the colons? I say colon before user ID and one after the presence. I don't know the syntax of what does it mean?
So a colon before makes it a symbol? Simple, yes. Jared knows more about this than I do, because obviously I'm just the UX designer.
Symbols are fancy names for immutable strings. They're very handy for cases like enums. Ruby does not have those, so these are that sort of substitute.
Okay, so that says that the user ID, which is a constant within a particular data set.
Yes.
And what is presence colon?
The colon in that instance is equals, or
Oh,
that's assignment. Must be true.
so what is the comma? I'm trying to figure out the syntax. What this is. Validates is a keyword it looks like.
So validates is actually a method because parentheses in Rails or Ruby in particular are optional.
I see, it's calling validates on two parameters.
And whenever you have options specified at the end, that end with a colon, you can attach a hash path of sorts to the end of any method called as additional options. So presence would be the key and true would be the value.
So this is to create data sets that you use to validate your whatever things you learn, predictors and models, things of this sort, right?
Right, you can imagine, you can use it for caption, if you've got images, people could be tagging the images, cat, dog, sign, to help you build a training set.
Okay, yes, so I want that the basic functionality here is that people can see two things, can say they are connected, or what is the basic functionality? Is that what it
Yes.
is? And of course, people can do things that are not true.
Absolutely, they could.
So, in my mind, if you have something of this sort, there has to be. So there are probably obvious protections. Nobody can perhaps vote twice. Vote twice.
No, they cannot vote more than once.
Unless they create a dummy account and create themselves as a dummy user, I guess. Because why would that system allow me to become a user of it?
All right, so let's say that happens. Let's say a user comes in, makes several accounts, which the registration process is, there's a lot of required fields. It's not super easy, but let's say they could do it. Let's say they make a bunch of dummy accounts. They'd have to go through every single combination of artifacts in order to find that same combination again, because it's randomly generated each time which source and which target you get. And it has to be one that you haven't voted on before. So for the Gantt chart data set example, there are how many artifacts on there? There's tons of artifacts on that. So it would be incredibly tedious and time consuming. And the odds are of somebody actually wanting to give malicious data is very small.
The other thing is, it's a community-based tool. So our plan is to, right now, use it with the traceability community, and we would only offer this tool for people who are in our community and allow them to get credentials to register and vote.
Yes, so then the people review papers, and they can say, the reviewers will say, okay, I know it's this community, but I have no idea whether all these people are qualified enough to make proper judgments.
put a notch in this, like for this user. They're now a better rater. So now, and this is going to be my question, is it possible to extend Scott's pie to have like a weighted view of users? So, so now inter-rater reliability means relatively little if all the people that agree are bad reviewers.
True.
But if they're like really, really good, then maybe they don't all completely agree, but it might be worth more than a bunch of not good users agreeing. I don't know, something like that. But that's what we need. That's a little frustrating.
It's a good point, though. It's a good point. What else? Go.
So you mentioned you're the UX designer, and obviously user interface is super important to getting correct data. So what was your hardest consideration when making design?
The original app that we were working from, the version 1.0 of this, was a bit crowded and there was a lot of text. So we wanted to keep as much as was absolutely necessary, but try to minimize the design so that people could solely focus on the content of the artifacts themselves. As you can see, like, with that many artifacts, there's literally so much data under the umbrella of one single data set, and obviously with multiple projects going and multiple people running multiple projects, it gets really heavy. So minimal design was the big push from me personally, because I wanted everything to be only the absolute necessary parts sticking out. Very important stuff. Because otherwise people are just going to look at it and say, I don't want to read all of this. Yes, they're related, I don't care. But we did actually move all the vote stuff to the bottom, so you had actually to go down through the content before you could actually vote. We were discussing putting the voting like alongside, in which case you could kind of avoid it. Not worth it.
So what happens if there are relationships that don't have a clear cut? I'm not clearly understood. I haven't. Many people say yes, many people say no.
Mm-hmm.
What happens then?
So that was some functionality that we've discussed several times about having controversial data sets highlighted for a specific user, that they would have another sort of tab to view.
I can show a bit on that.
Nice.
That was some tactic work. If we go back to our links page, we can see that a percentage match is shown, and whenever a vote or a link becomes controversial, it gets brought up to the top, and chances are if something is controversial, there's been several maybe votes, and if people have been generous, we can review that feedback and see why the controversy is there, and be able to edit our data set accordingly.
Pi equals 0, does that mean very confident or not confident?
That is not confident at all. This is based on the number of yes votes. As we can see, we've only got one yes vote so far, and that's because a random combination is significantly much more likely to be a no vote than a yes vote. MIDAS takes this into consideration, and whenever somebody finds a potential positive link, it's much more likely to present that to somebody else for confirmation. And as the number of positive votes increases, then we can finally perform a calculation using Scott's pie.
Is this actually in use?
Not yet, no. This is running on localhost.
Okay, well, good luck getting it to production, and thank you very much.